Hello students, today we start example of CPM, critical path method examples, and in a GTU examination this example asked in 7 marks. So here example data is given like from the data given below in table. So here one table is provided. So from the table prepare the network diagram and compute the activities time, total float, free float, interfering float, etc. and locate the critical path network of the project. So here we find out the network diagram. First we draw the network diagram, then after we find out the activities time, total float, free float, and interfering float, and also we find out the critical path of the project. So here this table is given. So in this table activities is given A, B, C, D, F, G, H, I, J, K, L. Activities arrow is given. Duration, time duration is given to complete the any work or a project. Clear? So here time duration is given, and also preceding and succeeding activity is given. Preceding and following activities is given. Like for activity A, so following activities are D and E, and in front of the A activity, none of the preceding activity. So here all the data is given. So from the data first we draw the network diagram. So here see this figure. So from the table we draw the network diagram. So in a network diagram, activity A arrow is a 1 2 1 3 and 1 4. So from the node 1 1 to 2 node 1 2 3 and 1 2 4. So this three line is drawn from the network 1 2 and 3. So 1 to 2 1 to 3 and 1 to 4 from the table. So here from 2 to 5 2 to 7 means from the two number node two arrow is burst, so 2 to 5 and 2 to 7. Clear? 2 to 5 and 2 to 7. Similarly from 3 to 5, so here so we draw the 3 to 5, this one 3 to 5, and then after from the table you exactly know from the 4 number two arrow is burst, 4 to 5 and 4 to 6. So this one 4 to 5, so like 4 to 5 and 4 to 6, and from the 5 number node 5 to 6 and 5 to 7 is drawn. So from the table we draw the 5 to 6 and 5 to 7 is drawn. Then after 6 to 7 only one arrow is given and 7 to 8. So all the network diagram activities is given like 1 to 2 arrow, 1 to 3 arrow, 1 to 4 arrow. So already activity is given like ABC. So like 1 to 2 activity is a 1 to 3 activity B, and 1 to 4 activity C. Clear? Now here duration is given for each and every activity. So each and every activity like activity A, 8 is given. Like a duration time 8 is given. For a B activity time duration is given 6. From the C activity time duration is 10. Similarly all the activities time duration is given. So this time we got from the table. So table is already given in a example. So here example data, this time duration is given as per the activity and arrow. So time duration is given is a different. Clear? Now here preceding and following activity is also given. So if we cross verify the activities arrow, so preceding and following activity, we exactly know about the preceding and following activity and particular activity arrow. So now after completion of the drawing the network diagram, first we find out the TE and TL value. So TE and TL value we exactly find out. So start to find out the T and TL value. First we draw the square box for the T and draw the triangle for a TL. So T always indicated by the square box. So start from the 0. Here for activity 1 to 2, here 0 plus 8, 0 plus 8. So time duration, after adding the time duration, T value for a 2 is a 8. Now then after 2 to 5, before 5 reaching the 5, here 3 arrow is merged. So 2 to 5, 3 to 5 and 4 to 5. So which one value is a maximum? So maximum value we count at a here as a T value for a 5. Clear? So here first we find out the 1 2 3. So 1 2 3 is a 0 plus 6 is a 6. Then after 0 plus 10 is equal to 10 for a 1 to 4. Similarly 10 plus 8 is a 18. 6 plus 10 16 and 8 plus 8 16. So from these three value 2 to 5, 3 to 5 and 4 to 5 maximum value we got a 18. So right here 18. Then after for a 6 number node, two arrow is merged 5 to 6 and 4 to 6. Clear? 5 to 6 and 4 to 6. So here 5 to 6, 18 plus 2 is a 20. Clear? And similarly 10 plus 10 is a also 20. So here both the value are same. So as per the rule maximum value we write, but here both the value are same. So write here 20 as a T value for a 6 number node. Then after 7 number node, 3 arrow is merged 2 to 7, 5 to 7 and 6 to 7. Clear? So 2 to 7, 8 plus 15. So 8 plus 15 is a 23. Then after 18 plus 10 for a 5 to 7 arrow. So 18 plus 10 is a 28 and 20 plus 8 is a 28. So maximum value is a 28. So right here as a T value for a node number 7. Similarly for a 7 to 8 arrow, 28 plus 7 is a 35. Clear? So we find out the each and every node T value we find out. Then after how to find out the TL value. So here ending is a 35. So right here TL value is a 35. Then after 35 minus 7. Here 35 minus 7 is a 28. 28 minus 8. So is a 28 minus 8 is a 20. Here at a 5 number node 2 arrow is here given. So here minimum value we write 28 minus 10. 28 minus 10 is a 18. 20 minus 2 is also 18. So we write here 18. Then after for a node number 2, 2 arrow is a 2 to 7 is a backward and a 5 to 2. So 15, sorry, 28 minus 18 is a 10 and 18 minus 8 is also 10. Clear? So here 10 value is the minimum value is a 10. So we write here 10. Then after 18 minus 10 is a 8 for a 3 number node and then after 20 minus 10 is a node number 4 TL value is a 10. 20 minus 10 is a node number 4 value TL value is a 10. Then after 10 minus 10, 8 minus 6 and 10 minus 8. So which one minimum value? 10 minus 10 is a minimum value is a we got a 0. So right here 0. So here one thing is clear that starting is a 0 and ending is a 0. So it's a main value of the T and TL for a first node. So starting and end value both are 0 and similarly end value is a maximum value for a T and TL both are the same. Clear? So now as per the rule, critical path is a maximum longest path is known as a critical path, or in another word, if the T and TL value are same, so passing from the path is a critical path. So here T and TL value is the same, is like 35 35 both are same. Similarly here 28 28 both are same. Here 20 20 both are same. 18 18 both are same. 10 10 value T and TL both are same. Similarly TL value 0 and 0, T and TL value 0 0 is the same. So here critical path is the longest path of the network diagram. So here longest path highlighted by the dark line. See this dark line? This dark line generally highlighted by dark line. So these are the longest path of the network diagram. So it is known as a critical path. Now in example, we find out the total float, free float, independent float. So before starting of the finding out the total float, free float, first we find out uh, earliest starting time, latest starting time, earliest finish time, latest finish time, and then after from the value of the earliest starting finish, latest starting finish, we got the value of the total float, TF, free float, FF, and independent float, IDF. Clear? So here first we start from the activity A. So activity A arrow is a 1 to 2 and duration is 8 is given. So earliest starting time. So from the figure you exactly seen earliest starting time is a 0 and earliest finish time. Earliest starting time is a 0 and earliest finish time is a 8. So here we write in a table is earliest starting time is a 0 and earliest finish time 8. Clear? Similarly for activity 1 2 3, for activity 1 2 3, so we write here for activity 1 2 3, these activities 1 2 3, earliest starting time is a 0, earliest finish time is a 6. So we write it here earliest starting time 0 and earliest finish time is a 6 from the figure. Similarly activity 1 to 4, for activity 1 to 4, this activity, so earliest starting time 0 and earliest finish time 10. So here same we apply, sorry we write it here earliest starting time 0 and earliest finish time 10. Okay. So similarly all the activities write from 1 to 2, 7 to 8. So all the activities earliest starting time and finish time write it here and in both the column. Then after latest starting time and latest finish time, we write from the figure like for activity 1 to 2, for activity 1 to 2, latest starting time is a 10 minus 8 is a 2 and latest finish time is a 10. So same thing is write in a table like latest starting time is 2 and latest finish time is a 10. Clear? Similarly for activity 1 2 3, so from the figure activity 1 2 3. So from the figure, latest starting time is a 8 minus 6 is a 2, and latest finish time is a 8. Clear? So all these things write at in a table, like 2 to 8, 2 to 8 is a latest starting time and latest finish time. Clear? Now here, total float, free float, independent float, we got from the earliest starting time, earliest finish time, latest starting time and latest finish time. So equation for a total float is a latest starting time minus earliest starting time. So latest starting time is a 2 for activity 1 to 2, latest starting time 2 for a 1 to 2 activity, and minus earliest starting time. So earliest starting time is a 0. So total float is equal to 2. So equation for a total float is latest starting time minus earliest starting time. So is called a total float. Clear? Total float is equal to latest starting time minus earliest starting time. So here we take another arrow like 1 2 3. So latest starting time for 1 2 3 is a 2, and late earliest starting time is a 0. So 2 minus 0 is equal to 2. Similarly, we take any another arrow like 6 to 7. 6 to 7 is a latest starting time is a 20, and the latest finish time is a 20. So here total float is a 0. Clear? So these are the simple and basic thing for finding out the latest starting time and earliest starting time. We find out the total float. Then after free float is a equation is the earliest starting time of the following activity and the earliest finish time of activity. So here we take a example like a free float is a earliest starting time of the following activity and earliest finish time of activity, or in another word, so earliest finish time of the present activity and difference between the earliest starting time of the successor activity. So here 8 minus 8 is equal to 0 for a free float. Now another is a independent float. Independent float is a free float minus tail event slack. So it's the equation for a independent float. So independent float is a slack time. So free float minus tail event slack. So here slack is same like here free independent float. We find out the 0 0 0 value. Maximum we are finding out the independent float at a 0 in each and every activity. Excepted 1 to 2 activities are we got the value, but in maximum activities we got the 0 value. So here example for the critical path method is finished. So in the next lecture we discuss about the another example. So here we complete our example. Thank you.